All right, welcome back, guys. We're on page 5. We're almost there. We just got this page left and a couple of open response problems. So on this page, it looks like we're doing sector area again. So let's put our pieces that we do know. We know the radius is 9 feet. Okay, we do know the partial degrees. The degrees partial is 115 degrees. We know that the whole degrees around a circle is 360 degrees. Okay, we also know, they said find the area of the sector shown. So we want to find this area in here. This is the area we're looking for. So we want to find the partial area. That's our question mark. And then finally, we know the area whole. We can find it using a formula called pi r squared, where r is 9 feet. So if we plug this in, sorry guys, to pi, then I'm going to get that the area of the whole is going to be 81 pi feet squared. Okay, and now if I set up my proportion, I got a proportion here, I'm going to set it up with AP is the one I'm looking for. I like to set those up in the top corner. So AP is to AW as DP is to DW. And so let's go ahead and plug what we know in. We don't know AP, so we do know AW. Sorry, AP is on top. AW is 81 pi feet squared. DP is 115 and DW is 360. I'm going to reduce while I can here. 5 goes into both of these. This is going to be 23, and 5 goes into that 72 times. Multiply both sides by 81 pi feet squared ends up putting this up here, and it's going to cancel out. So let me start over here. AP, we've moved the 81 pi feet squared up here, so it's 23 times 81 pi feet squared over 72. Now, I know 9 goes into both of these. 9 goes into this 9 times, goes into this 8 times. So I can see that the partial area, or the sector area as we call it, is 9 times 23. That 9 times 20 is 180. 9 times 3 is 27. So that's 207 pi feet squared divided by 8. And now there's nothing I can do to reduce here, but I could put this in decimal form just to have it rounded to the nearest tenth like the question asks us to. So I'm going to put it back on my calculator. 207 divided by 8 pi, and this should be, I better be careful with this, should be times pi. That's just a little bit of issue there, and it came out where I wanted. The 207 on top, the 8's on bottom, and the pi's on the outside being multiplied. So I'm going to change that. It's 81.29, and it said to the nearest tenth, so it's 81.3 square feet. Good. Moving on to the next one. Find the radius of a circle with a circumference of 60 meters. So I'm wanting to find the radius, and I know the circumference equals 2 pi r. But they also told me what the circumference is. The circumference also equals 60 meters. But since circumference is 2 pi r and circumference is 60 meters, I can say, you know what, I can replace this c with the 60 meters. And so I get 60 meters equals 2 pi r. Well, look, I can divide both sides by 2, and I get 30 meters equals pi times r. And that's times pi, so I'm going to divide by pi. Pi over pi. And 30 divided by pi meters is what r is, which is approximately going to be a little bit less than 10, right? 30 divided by pi, 9 point, and they wanted it round to the nearest hundred, so 9.55 meters. That's a nice easy one for us. Okay, find the radius of a circle with an area of 72.8 centimeters squared, round to the nearest tenth. Okay, so this is once again, I want to find the radius. I don't know it. I do know that area is pi r squared, and I also know they told me the area is 72.8 meters squared. Sorry, centimeters squared. And since these two are both a's, and I can set them equal once again. I can get, look, pi r squared equals 72.8 centimeters squared. Okay, so I could divide both sides by pi, and I could get r squared equals 72.8 centimeters squared over pi. Square root both sides, and I'm going to get r equals the square root. Now I don't have to worry about the negative one because once again it's length of 72.8 over pi. And when I square root a centimeter squared, I'm going to just get centimeters on the outside. So r is approximately square root 72.8 divided by shift pi. 4.81. So it rounds to the nearest tenth, so 4.8 centimeters. There we go. Find the circumference of a circle with a diameter of 16 inches, round to the nearest hundredth. Okay, so we know that d equals 16 inches, and we know that circumference is equal to 2 pi r, but there's also this other handy one that says circumference is equal to pi times d. Or, worst case scenario, if we don't know this one, we do know that r's takes 2 r's to make a d, so 2 times r equals 1d. And we can find out that r would have to be 8 inches. Either way we plug it in, what we're going to find is that the circumference is equal to 16 pi. And whenever I put that in approximation, and hit S to D if it wanted to give me a decimal, 50 point, and they said to the nearest hundredth, 50.27. And that was in inches, so those are inches. There we go. Nice and easy one. Find the circumference of a circle whose area is 90 meters squared. So this one's a little bit more difficult. We start with area equals pi r squared, but the area is also 90 meters squared. Circumference is equal to 2 pi r. And it looks like we may have to find r here to be able to use it to find c. So I'm going to set these two equal, and I'm going to get 90 meters squared equals pi r squared. And it looks like I'm going to divide both sides by pi. And I'm going to get r squared equals 90 over pi meters squared. Square root both sides, and I'm going to get r equals the root of 90 over pi meters. Okay, this will be 3 times the root of 10 over pi, but I'm just going to go ahead and pull that out now. R equals 3, because that's 90, 9 times 10, so 3 times the root of 10 over pi meters. But I need to use this with my 2 pi r to find what c is. So I'm going to come back up here, and I'm going to say, look, c equals 2 times pi times this 3 root 10 over pi. So let me get that up there. Meters. And so this is going to be c equals 6 pi root 10 divided by pi meters. I'm going to put that in my calculator. Now, by doing this, I've kept all the rounding errors till the very end here. So this is going to be 6 times pi times the root of 10 divided by pi, and I'm going to hit enter there. 33.6. C is approximately 33.6 rounded to the nearest tenth. Whew, we're getting there, guys. So a birthday cake is cut into 16 equal pieces. So let's go ahead and cut this cake. Let's see, here we'd cut it into 8 pieces. And this would cut it into 16ths. All right. So if I just connect a couple of these to get some slices, that's all I really care about is a couple of them. I know that there's going to be 16 total slices. So each of these slices will be 1/16 of the cake. Okay, that slice is 1/16 of the cake. And the cake has a diameter of 16 inches, which is the area of one piece of the cake. So this diameter is 16 inches. Now, should I cut that diameter down and say it's 1/16 of 16? So the diameter of a slice would be 1 inch? No. Now, areas and circumferences, they are proportional to the slicing into 1/16, but the diameter stays the same. The radius stays the same as long as you're taking slices from the center. So this is 1/16 of the total area. So here's what we know. We know that 1/16 will be the same proportion as the partial area is to the whole area. Now, do we know the whole area? Well, we can replace it with pi r squared, right? And we do know r. Well, we know that d is 16, so that means that r would have to be 8. So 1 is to 16 as the partial area is to pi times 8 inches squared. Don't forget my units, inches. Okay, so I'm going to multiply both sides, and basically this is just going to end up moving up here. Okay, and I'm going to end up having 64 pi inches squared over 16 equals a, the partial area. I know that 16 goes into 64 4 times, so that means that the partial area is equal to 4 pi square inches. I would prefer it like that, but I'm sure that they're going to ask you to round. So 4 pi rounded 12.57 square inches is your portion. Okay. Okay, and I'll be doing these last ones on the final. This is the open response. I'll be doing these last ones on the final take.